Hi everyone, my name is Steve. So I just took the AWS Certified Developer Associate exam this week and passed it. So I'd like to take a few moments to make a video to document how I prepared for this exam and passed it, as my memory is still very fresh. So stay with me for that. Again, just to quickly show you guys the exam, so you can click digital badges. Just wanted to quickly show you guys after you pass the exam what you are going to get. This is the third one that I'm talking about today, which is the one that I just passed, which is Certified Developer Associate. And the previous two is a Certified Cloud Practitioner and a Certified Solutions Architect Associate. So I have two videos to talk about each one of them. You can just click right above, check out those two videos. And today I'm going to talk about AWS Certified Developer Associate and how we can prepare and pass it. The name of the certificate is called AWS Certified Developer Associate. It's still associate level, not professional yet. Passing score is 72%. It's going to be scored a total of 1,000, but as long as you get over 720, you are considered pass. Exam duration is a little bit over 2 hours, 130 minutes total. Exam format is still the same as the previous two exams, multiple choice, single response, or multiple choice, multiple responses. Exam cost is $150. You can schedule it online either with Pearson VUE or PSI. Expiration is valid for 3 years. It's long enough. So every 3 years you want to refresh your knowledge with AWS. And then I want to talk about how I prepared for this AWS Certified Developer Associate exam. I mainly used WizLabs. Again, this is a very cool website, and the rich feature that it provides really saved me a lot of time. So I logged into WizLabs, I clicked on My Courses, and I went into this one, AWS Certified Developer Associate. It provides a lot of different practice tests, online course, labs, report my certificate. The one that I really like is the practice tests. There are 5 of them, and there's a final one, which is the final test. So a total of 6 complete tests. You can see that I finished all of them. I think for one of them, I even took it twice. I really like it. Then there's 5 individual section tests, DynamoDB, Lambda, API Gateway, KMS, CI/CD. These are the ones that I'm going to cover in the short second. But they provided individual tests to help you dive deep. For example, for DynamoDB, there's how can you do the math to calculate how many RSU, read capacity unit, or WCU, write capacity units that you need to meet your specific application needs, right? And also for all of the practice tests is super cool. Let's just, for example, take a look. When I went through the questions, I made my best educated guesses if I don't really understand the question, but still I made wrong choices. What saves me time is that there's the explanation section, which is my favorite part. It clearly lists out why option A is incorrect and why option C is correct. So it saves you a lot of time. Plus it puts an official AWS link in here. If you still want further information, you can just click through that. So after this, I had a better understanding of the entire exam. So I highly recommend take a look at WizLabs, go through the sample practice tests and play around with their labs. It's going to prove super helpful for your preparation of the AWS certification exams. Now let's break down the exam. The exam, it consists of 5 different components or domains. Number 1 is deployment. Number 2, security. Number 3, development with AWS Services. This is the core, the meat of this entire exam. Number 4 is refactoring. 5 is monitoring and troubleshooting. Total, these 5 domains consist of 100%. Now let's take a deeper dive into each of the domain. Number 1 domain is deployment, which is about 22% of the entire exam. CloudFormation is a very powerful service. So first you need to understand what is CloudFormation, what does it do? For example, you need to be able to handle questions like how to make templates that can be used across multiple accounts and regions with the least amount of effort. In this case, we can use AWS CloudFormation stack sets. So this is a feature of CloudFormation, which is going to be very handy. Which command or which script can use to configure instances, for example, with Nginx web server. You need to know you're going to use cfn-init, this helper script inside CloudFormation. Just some examples. Second one, Route 53. One use case of Route 53 in deployment is that we can use Route 53 weighted routing policy to manage blue-green deployment. So you need to understand if you want to do a blue-green deployment, which service can you use in AWS? That is Route 53, just an example. Code deploy, of course. For example, you need to understand what's the right sequence of hooks during a deployment could be called. There are 4 hooks. The right sequence is application stop, then before install, then after install, then application start. These things that you need to understand. Of course, you want to understand what is called immutable updates, what is rolling updates, and also you want to understand which deployment method could keep the entire fleet to maintain its full capacity. One possibility is immutable deployment. The other one is rolling update, but with additional batch, so that we can keep the entire fleet at its full capacity. And also you want to know which file is used to specify how your application will be deployed to the underlying EC2 instances. That is the appspec.yaml file. You can specify your configuration either in JSON or YAML format, but not XML, only JSON or YAML. You really want to play around with all of these tools. Just open up your AWS console, play around with it, but don't forget to stop all of your services, otherwise you might incur unnecessary charges. CloudFront. CloudFront is for web distribution. You need to understand what CloudFront is and what it helps for which use case it helps. For example, to handle cases like you want to control how long your objects stay in the CloudFront cache before CloudFront forwards another request to your origin. What would you do? You can configure your origin to add a cache control or an expires header field to each object. Or you can specify a value as a minimum TTL in CloudFront cache. And how do you configure CloudFront to require HTTPS between viewers and CloudFront? You can either redirect HTTP to HTTPS, or you require HTTPS only, things like this. And then ops work. Ops work is best suited when you have multiple stacks and you want to use configuration tools for the environment. Elastic Beanstalk. This is a very heavy component. To best understand this component, you really want to open up your AWS console, play around with deploy an application using Elastic Beanstalk. Then you will have a better understanding. Elastic Beanstalk supports two options of saving configuration options. One is YAML, the other is JSON. Both can be included in your application's source file in the directory named .eb extensions and deployed as part of your application code. Another often asked question is if you want to deploy a worker application that processes periodic background tasks, your application source code bundle in Elastic Beanstalk must also include a cron.yaml file. Another typical question is the least amount of time or effort needed to provision an application using Elastic Beanstalk with unique configuration files and software to include, which is to what? Which is to use a custom AMI, Amazon Machine Image, for the underlying EC2 instances. So again, Elastic Beanstalk is a very critical and important component. You can expect that to be tested and asked again and again during the exam. So play around with that. Use your hands-on experiences to help you understand. Code pipeline. Based on its name, is for deployment. You can create custom actions with AWS Code Pipeline. For example, a job worker needs to be created on any device which has access to the public endpoint for AWS Code Pipeline. Then Code Build. Code Build is Amazon's building system for building your code. AWS Code Build supports a lot of different locations. For example, AWS Code Commit, S3, GitHub, Bitbucket. It supports all of these. And also you want to understand how do you allow an application that needs to access an RDS instance, for example, in the private subnet when using Code Build to build his code. In this case, you want to provide additional VPCs specific configuration information as part of your AWS Code Build project. For example, your VPC ID, your subnet ID, or your security group ID. It's going to be a mix of different services. For example, when it's asking the question that I just mentioned, it's testing your understanding of Code Build and VPC, subnet, security group. So it's going to be an integration, combination of different services, features. As a rule of thumb, just to play around with your AWS services. And then Code Commit. Code Commit is basically an AWS hosted version of Git. You can migrate any version control system, your customized version control system, to AWS Code Commit. But remember, you need to migrate it to Git first. You can migrate to Code Commit in a number of different ways. You can clone it or mirror it or migrating or just part of your branches to Code Commit. The easiest and most secure way to share a repo is to create Git credentials for the IAM users and to allow the developers to connect via HTTPS using the Git credentials. This is the easiest way. And then, of course, in terms of deployment, we'll have to talk about Jenkins and continuous integration and continuous deployment. For example, you need to understand as a best practice, when you use a Jenkins build provider for your pipeline's build or a test action, you want to install the Jenkins on your Amazon EC2 instance and configure a separate EC2 instance profile. The second domain is security, which covers 26% of the entire exam. First is AWS Secrets Manager. This is a service that AWS provides which helps it easier to manage secrets. For example, your database credentials, your password, your API keys. Of course, you don't want to embed or hardcode them in your code, which is very bad practice and leaves your application at risk. So you want to take advantage of Secrets Manager, which was designed and built just for this purpose, to help developers easier and better to manage their credentials or secrets. AWS KMS, this is a very key and critical component. It appears in a lot of exams. For the exams that I took, Certified Cloud Practitioner, Solutions Architect Associate, and the most recent one, Developer Associate, everywhere is asking you KMS because security is built into every single layer of the AWS services and should be built into your application as well. KMS stands for Key Management Service, which is a very powerful tool. You need to understand there is server-side encryption with AWS KMS keys, and there is server-side encryption with customer-provided keys. You need to understand the difference, and there's also client-side encryption. By default, KMS doesn't support asymmetric keys. Instead, they support symmetric keys, which never leave KMS unencrypted and is used to integrate with other AWS services. And also, for example, you need to understand for use cases like for a company, there is a temporary audit. How do you provide temporary access to external auditors? So you want to use grant tokens received from an API called create grant request after using grants with decrypt and re-encrypt operation. And also for KMS, there are two very important APIs. One is called generate data key. The other is called generate data key without plain text. Both of these APIs are used to get a data encryption key. The difference is that the later API, which is called generate data key without plain text, it returns a data encryption key encrypted under a customer master key, but it only returns the encrypted copy of the data key. While the first one is called generate data key, it returns both the original plain text key and the encrypted copy of the key. Understand these nuances will help you perform better in the exam. And then there's AWS Cognito. This one, I've seen questions regarding AWS Cognito, at least 2 or 3 questions in the real exam. There is AWS Cognito Identity Pool, AWS Cognito User Pool, and how do you block compromised users? This is an advanced security setting. And there is Cognito Sync. This is a feature which enables users to do cross-device syncing of application-related user data. And how do you sync the offline data back to AWS? AWS Cognito Sync will also push sync notification. And then there is AWS IAM, which stands for Identity and Access Management. This is a very, very powerful and critical tool. Almost all applications that's built on top of AWS will have to deal with, or will have to take advantage, will have to use IAM, because basically every service or every application needs authentication or authorization. You need to understand role, user, and group. These are the 3 basic concepts within IAM or within any identity and access management services. There's CORS, which stands for Cross-Origin Resource Sharing. This could appear either in security or in, for example, it could be embedded within a question asking your understanding or knowledge about API gateway. For example, there might be a question asking, when using S3 to host a static website, a browser usually blocks JavaScript from allowing the requests. What would you do to help enable such requests? So you want to use CORS. You can configure CORS to configure your bucket to explicitly enable cross-origin requests from your domain, things like this. So number 3, this is the heaviest or the core part of this exam, which is to how do you develop services? How do you develop your application, your services in your infrastructure on top of AWS? It has 30%. The order doesn't really matter. I'm just listing things out as I recall. RDS, Relational Database Services. Of course, this is very critical. Every application needs a database. You either use SQL services or NoSQL services. For SQL services, for example, you can use RDS. For example, you want to understand, you need to get the endpoint. You can either call the API or you ask the administrator to log into the AWS console to get the endpoint instead of the IP in order to connect to your RDS DB instance. And also a question like, how can you make sure that the connection to the DB from your application is encrypted? The short answer is that you can use SSL. Number 2 is you want to develop applications against AWS. Of course, you are going to use AWS CLI, which stands for Command Line Interfaces. This is very handy, super handy, I would say. There are all sorts for every single AWS service, S3, EC2, DynamoDB, RDS. They all provide AWS CLI, which is super, super handy. You can just fire up your terminal and type different things to check the services, your data inside AWS SDK. This is very near dear to the heart of every single developer. How do you interact with AWS? Of course, you need to call their SDK. For example, DynamoDB SDK, S3 SDK, EC2 SDK. Call the SDK to interact with them, read or write or overwrite data. And just to talk a bit more about CLI, you want to understand, for example, there are tricky questions like, it's not actually tricky if you really have hands-on experiences with AWS, those questions are really fine with you. For example, if you set environment variables with your access keys, these will actually take precedence over IAM role. So you might get tricky questions. What if a developer A changed his IAM role from read and write to read only, but still he finds that he can still write into an S3 bucket? Why is that? That is because he set his access key in the environment variables, which has precedence over IAM roles. So understand these. So if you open up AWS SDK, for example, for S3, you'll see that how does it instantiate AWS S3 client is that it has a chain of credential providers. Number one is that it is going to retrieve credentials from environment variables. If it finds credentials from environment variables, then it's good. It's not going to look elsewhere. Only if when they cannot find credentials or access keys from environment variables is going to go down the chain. The next one is Java system properties. Then the third one is default credential providers. For example, those located under .aws .credentials. So you need to understand the change. Just open up AWS SDK source file. You'll have a better understanding. Access keys consist of two things. One is the access key ID, the other is the secret key ID. You can use these two things to make API calls. You can also make REST API calls, SQS. If I recall correctly, this is the very, very first service that AWS launched. It's not a S3, it's actually SQS, Simple Queue Service. This is the very critical service that could decouple your monolithic services to help developers build microservices and to connect the loosely coupled microservices together and to provide high availability. There is a message size limit for SQS, things like that, to delay seconds, to delay time on individual messages instead of on the entire queue. You can use message timers. This is a little bit nuanced that you can play around. Again, fire up your AWS console, play around with it. Then there's SNS, which is often used in combination with SQS. SNS is a topic that you can publish messages to, and then SQS, you can use like one or multiple SQS to subscribe to one SNS topic. EC2, for sure, everybody knows EC2 is virtual servers standing in AWS to service your request. S3, for sure, that's the storage of the entire internet, provides 11.9, super high availability. And also you want to understand the server-side encryption with S3. A couple numbers you want to understand. S3 provides 3,500 put requests per second for every prefix in the bucket. And also S3 provides 5,500 get requests every second for every prefix in the bucket. And there is no limit for the number of prefixes in the bucket. So if you really want to balance out the requests that get sent to your S3, you want to create a good number of prefixes in your bucket so that you can max out the throughput. And also there is cross-region replication in S3, which could help to minimize your latency to increase operational efficiency. And also it could maintain object copies under different ownership. That's for cross-region replication in S3. And also a very key for S3 to remember is that you don't need to randomize prefixes anymore. Since 2018, which AWS released a very major performance improvement for S3, since then you can use sequential database naming for your prefixes. And there is another cool thing that I learned is if you see a significant increase in the number of HTTP 503 responses from your S3 requests, you might have one or more objects for which there are millions of versions. The reason that S3 throws 503 is that S3 automatically throttles your requests to the bucket to protect the customer from an excessive amount of request traffic so that no excessive costs are going to occur. And to fix this, to determine which S3 objects have millions of versions, you want to use Amazon S3 inventory tool, which is going to generate a report that provides a flat file list of objects in the bucket. Then there's API gateway, which is super cool, super easy to use, play around. I strongly suggest you just set up an API backed by a Lambda function or whatever, just play around with that. You'll have a better understanding. For example, you can just expose the get method in the API gateway so that users could call your backend Lambda services or whatever. And for every single version of your API, in order to let it take effect, you need to deploy that. You always want to associate a stage with an API gateway. Then there is Elastic Cached, which there are two different call versions. One is memcached, the other is Redis. A core difference between these two calls is that memcached doesn't support high availability. However, Redis, it provides cluster mode, which supports high availability. Then there's Lambda and serverless. I would guarantee you it's going to ask at least 3 or 5. That's the minimum questions about Lambda in your real exam. So play around with that. It's the future of computing. Which means you don't need to worry about the servers. You just write your code and deploy it. That's it. You let AWS to handle the server management. And another thing to note is how do you make a Lambda function to run on a scheduled basis? In the AWS, we can use CloudWatch events to schedule when your Lambda should be run. And if an error happens or during your development phase, you want to check and debug a Lambda function, what would you do? You want to use a dead letter queue. There is Kinesis. At least 3 or 5 questions are going to be asked about Kinesis. Kinesis firehose, Kinesis data streams. For example, how can you calculate the initial number of shards of your Kinesis? You need to know 2 numbers. One is the incoming write bandwidth. The other is the outgoing read bandwidth. And then how can you analyze data using standard SQL in Kinesis? You want to use Amazon Kinesis Data Analytics. That's another service provided by AWS. Then there's Amazon ECS, Elastic Container Services. For example, you want to know where you can store Docker images. You can store them in ECR, which is Elastic Container Registry, which is a service provided by AWS, or you can store them in Docker Hub. But you cannot store them as AMI, which is Amazon Machine Image. You cannot do that. And also remember, ECS has orchestration built in. DynamoDB, that's the crown of AWS. Arguably, it has unlimited scalability. And of course, it's going to ask you at least 5 questions about DynamoDB, if not more. For example, you want to understand the hash key, partition key, range key, sort key. They are sometimes used interchangeably. You can use DynamoDB TTL to safely and automatically delete items in your DynamoDB table based on the TTL values that you specify. And also, you want to understand what are the best practices when it comes to designing your DynamoDB table indexes. For example, you want to keep the number of indexes to a minimum. You don't need to create a second indexes on attributes that you don't query often. The reason is indexes that are rarely used could contribute to increased storage and the I/O costs without improving application performance. And also you want to avoid indexing tables that experience heavy write activity. Along with DynamoDB, there's DAX, which is Amazon DynamoDB Accelerator, which is a dedicated service designed to cache DynamoDB requests. It will automatically add the data in DAX if there is a cache miss, or update the data if it is updated in the table. It is a very fast in-memory store, so it provides single-digit millisecond to microsecond latency. And also another key part is you need to understand how to do the math related to DynamoDB. And I got one question about this, and this is something that you definitely need to understand and make sure that you got that one right. For example, given 400 items, each item is 5 kilobytes. For every minute, you want to write this in a strong, consistent manner. How many read capacity unit do you need? Another question is, how do you know how much consumed capacity of your DynamoDB table has been used after this query? So you want to ensure that the return consumed capacity, this field in your query request, is set to total. That is what I have listed for AWS services. Of course, there is going to be more. The fourth domain is refactoring, which has about 10%. Step function is a very cool function. It can help you visualize and help you to coordinate different parts. For example, you can have different Lambda functions to be coordinated through step functions. Then there is AWS data pipeline. Data pipeline, you need to know there is something called data nodes, which define source and destination locations. And then there's Amazon Redshift. For example, how can you load your data, your large amounts of data from S3 to Redshift? You want to use the copy command, COPY, in uppercase. These are just 3 of the ones that I feel related to refactoring. Of course, there is going to be combination or different integration of services. That's part of the refactoring domain. The last one is domain 5, monitoring and troubleshooting. it's about 12%. CloudWatch, this is super powerful. I think it's built in with almost every single AWS service. For example, SQS, SNS, DynamoDB, RDS, it always has CloudWatch by default enabled, if I recall correctly. For hybrid mode, some development teams, they don't migrate 100% into AWS. They might have some of their services on-premise and part of their services migrated into cloud. In that case, how can you monitor your on-premise services? You can deploy a CloudWatch agent onto your on-premise servers, which is super cool, so that you can use CloudWatch metrics to monitor your on-premises metrics as well. And then there's AWS Accelerator, which, as its name indicates, is going to help us troubleshoot. For example, how can you trace all incoming HTTP requests using Accelerator SDK? In this case, you can add interceptors to your code. All right, if you have any questions, comments, leave me down in the section below. And if you find this one helpful and you passed your exam, please come back to this video and leave a comment below. Would really like to hear from you guys. And also, I'm going to put a few links to some of the very helpful, useful resources that helped me prepare and pass the exam down in the description box below. So definitely check that one out. Good luck with your effort and your exam.